Hello everyone, in this video we'll see binary trees level order traversal. We are given one binary tree and this is the node definition. We have data and right and left pointers. So what the task is, in each level you have to print these numbers. Here in this tree, this is level 1 and this is level 2 and this is level 3 and this is level 4. So you have to print like 1 then 2 3 and then 4 5 10 and 11, and next line how to print 6 7 8 9 11 13 14 and 15. And this is my code how do we going to approach the problem. Here I have level order function. It expects a root node and a vector integer and then current level is nothing but the height. So next line, if the node is null we have to return, and next line is in this vector for this specific height we have to add that node's data, and then we have to travel the left subtree with the current height plus 1, and we have to travel at the right side the current level plus 1. We'll see few more examples and I'll explain this code. Here we have 10, so L1 10, in L2 20 and 30, in L3 40 50 60 70, it's there. And in this tree you have 10 and the next level it's 10 and 20, and L3 it is 40 and 60. Now in this tree, first level you have 10, second level you have 20, third level 30, fourth level 50, and fifth level 60 and 70. So we go to the first tree. So what I have is I am given with this root node as 10. So it comes to the code and it checks if the node is null. It is not. So it will go to the next. What here I have is I have this kind of list array. That is nothing but the vector array. This is the one vector and this is the second vector and this is the third vector. Combined all together is a one array. So in first one I have L of 1. So here current level I am passing as 1. So 1. So level of 1 is adding this node's data. So what the node's data is 10. So it is added. The next line is we have to go to the left side. So here it will take this 20 node as a next recursive call as root node, and then current level we have to add plus 1 because we are switching downwards, so we have to add plus 1. So when it comes to the next one, so already 1 is there, here we are adding 1, so 2. When it comes to the next recursion call, the current level will become 2. So here level of 2 we have to add this 20, so 20 is added, and then next call is left. So I'm going to this left. Here you have to add, then this level is 2, so 2 plus 1 it's 3, so I have to add L of 3, this data as 40. Okay, now this left is again triggers, then the right and left is null, so it will return, and the next call for this 20 is the right side, so it will take this 50, and here I have one more level, so here itself 2, and for this one 2 plus 1 it is 3, so it will add it to the 50 in the third list. Okay, now this side is out and we have completed this 20 also, this 10 also. So what we covered is these 4. Okay, now it have to travel in the right side, so 30, so how to add plus 1, so it will go to the level 2, so 30 is added, and then you have to travel at the left. Here 2 plus 1, so third level, so third level also it's 60 is added. Little check, nothing is there, so it comes out. So then 30 will continue its right side, so 2 plus 1 again it's 3, so 70 is added. So this is our approach to solve this problem, and we have to print this lists of vectors. So okay, now we switch to Visual Studio Code. Here I have necessary importing statements, and next is I have node class. Node class having some public properties like in data and pointers left and right, and here I have constructor, and in main function I have all these three trees. This is first tree, and this is second tree, and this is third tree. I have corresponding the code representation in these lines. Okay, now we'll directly write the program. So what I do is void level order. It expects three arguments, so node, root, and vector int levels, in levels array, and then int height. Okay, our first condition is if node is null, root equal to null, then return. If it is not null, so levels of height dot push back this roots data. Next is I have to travel right side and left side, so level order, the same root left data, and levels and height plus 1. Height is the current height, and I need the same one for right side also. Right. Okay, here I have to call that method and print the contents of this levels vector. So what I do is first I call this. Before that I'll just declare this levels int levels of 100. You have to pass this n in this level order, so n comma level comma 1. Once I call this, I have to print this. So what I do is I declare the integer variable int I equal to 1. So while this levels of I dot size not equal to 0, I have to print this. For int j, here levels of I dot size, here in cout how to print levels of ing, and once I print that level, you can clear that levels of I dot clear and I plus plus. Here you can remove these excessive braces. After clearing this interval, just write cout indel, and let me just run this program and we'll see. Here you have 10, 20, 40, 50, 60, 70. Here you have this output of this list. So let me just clear this and see. In L1 it is 10, L2 it is 20 and 30, L3 40, 50, 60, 70. So we got that output, and we'll try for other trees also. So copy and paste it for M. And here just duplicate declaration, I remove it. Okay, now it's ready, and I'll copy the same thing for the next tree also. Here it is Y and Y. Format the document and run. Okay, here I include one more cout handle to make you to understand a clear output. Okay, here in the next tree you have 10 and 20, 30, 40, 60. Here the same thing. And the next one is a file list 10, 20, 30, 50, 60, 70. 10, 20, 30, 50, 60, 70. So all the test cases are passing, and hope you understood this problem and solution. Thank you for watching this video. We'll meet in the next video.